Hello, welcome back. Before I start parametric equations, related rates and so on, I want to spend just one lesson giving you ideas on points of inflection. A point of, for example, if you take up the graph of y equal to sine x, if I draw let's say that's the graph of y equal to sine x, I'm looking at the origin, right? If I draw the tangent to the curve at the origin, yeah, you see that particular tangent crosses the curve. Whereas if I draw the tangent here, it does not cross the curve. It still meets the curve at one point there, but it crosses the curve. So, at such a point when the tangent crosses the curve is a point of inflection. So, not every point is of course, most of you have this misconception that any point where d squared over d squared is 0 is a point of inflection. Remember, when I did maximum minimum, I took two examples to show you it's not necessarily a point of inflection, and I also told you that I'm going to talk about it later. So that later, of course, you may not remember, you've forgotten because perhaps you didn't even see that video, or perhaps your teacher told you but you didn't. That was done in year 12, sir, we have forgotten. Possible, so I'm just going over. So, whenever a tangent crosses the curve at the point of contact, not tangent intersecting a curve somewhere else, at the point of contact it crosses the curve, then you get a point of inflection. So, there are two conditions of point of inflection. One is that the gradient is maximum or minimum. When is it? Look, the curve is maximum or minimum when the gradient is 0. That means the rate of change of y with respect to x is 0. A gradient is maximum or minimum when the rate of change of gradient with respect to x is 0. That means d squared y by dx squared. So therefore, for a point of inflection, first condition is d squared y by dx squared must be 0, let's say at x equal to a. If at x equal to a, d squared y by dx squared is 0, then it could be a point of inflection. It's still not necessarily a point of inflection. The other thing we look at is d squared y by dx squared changes sign as x passes through a. Meaning the sign of d squared y by dx squared, as x increases should go from positive to negative or from negative to positive as the case may be. Okay, so let's look at some examples. Find whether, so those are two conditions. So find whether origin is a point of inflection. I don't know whether this is necessary for A level. Some boards do have it. Point of inflection on part A, y equal to x power 6 and y equal to x cube minus 3x. Yeah, fine. What the first condition of a point of inflection? D squared over d squared. So what's dy by dx? 6 x power 5. What is d squared y by dx squared? 30 x power 4. Equated to 0, x equal to 0, y equal to 0 is the point where second derivative is 0. But is it a point of inflection? Okay? To do this, what you do is take a value less than 0. Say minus 0.1. What is the sign of d squared y by dx squared? X less than 0, d squared y by dx squared is positive. X greater than 0, d squared y by dx squared is still positive. That means there is no change in the sign of d squared y by dx squared. So, not a point of inflection. What about here? What's dy by dx? Is 3x squared minus 3. What is d squared y by dx squared? 6x. When you equate it to 0, x is 0, y is 0. If x is negative, do you agree d squared y by dx squared is, when I say negative, please don't look at minus 2172. We're looking at as x increases from one side to the other side of the point. So the point is x equal to 0. So minus 0.1 and plus 0.1. X greater than 0, d squared y by dx squared is greater than 0. So therefore, the sign of d squared y by dx squared changes as x increases and passes through the value of x, which d squared y by dx squared is 0. Then it is a point of inflection. So 0, 0 is a point of inflection on that curve, whereas d was 0, 0 is not a point of inflection on that curve. Incidentally, that's a odd function, that's an even function. So there is a possibility that an odd function will have a point of inflection, generally speaking, but that's not a rule, as you will see in the next question. Is that clear so far? Understood the definition of a point of inflection? Point of inflection is where the tangent at the point of contact crosses the curve. Let's take another example. Show that or find in the range minus pi over 2 less than x less than pi over 2 the points of inflection. There is one topic which I have not done, which I am not going to bother. Pretty simple, increasing and decreasing functions. You could do it on your own. Dy by dx is positive, find the range of values of x. Dy by dx is negative, find the range of values of x. You could do that. I'm not going to do the point of inflection on the curve y equal to cos 3 cos 2x. So what do? Find d squared y by dx squared. dy by dx is minus 3 times, 3 times cos 2x gives you minus sin 2x, 2x gives you 2, which is minus 6 sin 2x. D squared y by dx squared is minus 6 is a constant, sin 2x gives you cos 2x, 2x gives you 2. So minus 12 cos 2x. Yeah? Now equate it to 0. So PV is pi over 2. So 2x equal to 2 pi n plus pi over 2, 2 pi n minus pi over 2. You see, trigonometric equations, differentiation, trigonometry, you can't get rid of it. So x equal to pi n plus pi over 4, pi n minus pi over 4. Put n as 0 I get pi over 4 and then minus pi over 4. Put n as 1, it will be 3 pi by 4 and 5 pi by 4 and minus 3 pi by 4. So those are the only 2 points. So x equal to pi over 4, y equal to 0, x equal to minus pi over 4, y is 0. Those are possible points of inflection. They are not yet points of inflection. So let's look at this. X equal to minus pi over 4. Suppose I'll take minus pi over 4, minus 45. So minus 60 and then minus 30. Let's look at d squared y by dx squared. 60 times 2 is, mentally I'm doing it, you can use a calculator. This doesn't matter, I'm only interested in the minus. Even that doesn't matter, as we will see. 60 times 2 is 120, minus. Cos of minus 120 is cos 120, which is minus half, and the minus is a plus. And then what about the other one? Cos of 2 times pi over 3 is 2 pi by 3. Okay. Minus pi over 6, idiot. 30. 30 times 2 is 60. It's a minus. So look, d squared by dx squared changes sign as x increases from minus 60 to minus 30 through minus 45. So that's a point of inflection. Do the same thing. Of course, let me put a minus pi over 4 there and a plus pi over 4 there. If you do for 45, 30, 45, 60 goes from minus to plus. Same story. So therefore, whenever you are asked to find point of inflection, not enough if d squared or by dx squared is 0. Like you did in gradient rule, take a value to the left of d squared or by dx squared, to the left of x, take a value to the right of x, put in the values into d squared or by dx squared, check whether you get a change in sign. If you get a change in sign, it is an inflection. If you don't get a change in sign, it is not an inflection. So that is how, this is something which we rarely teach because it's not very common in the exam. That's why we sometimes, over the years we tend to ignore it. But I thought since the syllabus has been revamped and revised, it might be useful to have that at the back of your mind about how to find points of inflection. So I just took some examples to show you. So to recollect, remember dy by dx equal to 0 gives you stationary values. But if dy by dx is 0 and d squared y by dx squared is 0, there is no guarantee that it is a point of inflection, because if you took y equal to x power 4, it would be a minimum point, whereas if you took y equal to x power 3, it would be a point of inflection. So it depends. Yeah. So I don't want to go beyond that. So I'll stop at that stage. In the next few lessons, I will first deal with parametric equation. That will take me about 2-3 lessons. And then I will take up 2 lessons, I think, on related rates and one lesson on rates of change. Then I'll do a bit of algebra before again coming back to the longest topic you have apart from differentiation, integration. Remember, as I used to tell my students, differentiation, integration, differential equation and trigonometry is about 60%. If you're thorough in those 4 areas, you automatically have a C. If you're good at differentiation, if you're good at trigonometry, if you're good at integration, if you're good at differential equations, only those 4 topics, you can easily get 60%. Easily. And that means you're already in a C, somewhere around a C. So the A and A star depends upon how good you are in algebra, how good you are in coordinate geometry, how good you are in functions. Those are the things that add up to get you from a B to an A. So the most important topics first, you know, like you first reach a particular level and then you climb up, right? You don't suddenly jump. So become very, very proficient or very good in differentiation, integration, trigonometry. Then you're assured of you will not fail. You will not see a U or a D or an E. I think the minimum you can get would be a C. That's my reading. I could be wrong. But based on my experience and looking at so many past papers, I don't think you will be wrong. I don't think you will go wrong if you're very good in these three. Obviously, of course, the implication there is if you're good in these three, somewhere you'll come across algebra, so you'll be good in algebra as well. May not be arithmetic sequence, geometric sequence, blah, 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 but generally. So, I think you can be assured of a C if you're good in these three topics. Leave you at that. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.